appreciate everybody coming out this morning. My name is Tom Clausen. I'm in the education office here. I'm a K-12 education officer, and I am delighted to see a few students here. I was concerned about sending out too many invitations because, as we all know, it's a school day, and it's an early hour. Nevertheless, we're glad you're here. We're enthusiastic about this return to Flight 2, and we're glad to have you here. We'll be going through the whole thing with you, and we appreciate you being here. Can you hear me okay back there? Okay. No? Okay. Well, listen up. Now I'd like to introduce one of our directors. We are supported in our organization across the center by wonderful people that help us get the support that we need to do our jobs and pull off things like this. And Deb Fang has worked here at Ames for a number of years in a number of different capacities, and has been instrumental in many of the things that go on here. Presently, she serves as the Associate Director for Mission Support, which really means that she's involved in almost everything that goes on here at Ames. Please welcome this morning Ms. Deb Fang.
Good morning.
Hi there.
Gosh,
Good morning.
It's early.
Yes.
We're late.
Yes.
Depending on your perspective. I'm so glad that everybody's here. Thank you for joining us this morning. We're all very excited. We're all very excited. So I'm going to act like this is actual morning for me. We're all here to see the launch of the Orion spacecraft, a critical step in NASA's journey to Mars. Speaking of Mars, NASA is developing new technologies and capabilities to send astronauts farther than ever before, first to an asteroid and then onward to Mars. Astronauts aboard NASA's Orion spacecraft, launched on Space Launch System rocket, will explore an asteroid in the 2020s and return to Earth with samples. The experience will help NASA test new systems and capabilities needed to get to Mars. Back here on Earth, Ames Research Center played a critical role in the development and preparation for a flight test of NASA's new spacecraft, Orion. Designated Exploration Flight Test 1, or EFT-1, the mission will provide critical data that will enable engineers to improve Orion's design and reduce risk for the astronauts it will eventually carry. One of the biggest challenges for Orion is that it will re-enter Earth's atmosphere faster and encounter more heating as a result than any previously manned missions, including Apollo and the Space Shuttle. To test Orion's new heat shield, made of material called Avcoat, Ames used its ArcJet facility to simulate the heating and airflow conditions that occur during atmospheric re-entry. During these tests, the Avcoat surface reached temperatures of about 4,000 degrees Fahrenheit.
Wow.
Ames developed 34 sensors that were built into the heat shield and itself to monitor how well it performs during EFT-1. The Ames sensors, part of 1,200 sensors on Orion, will measure the near surface and internal temperatures of the heat shield as Orion re-enters the atmosphere. This will give engineers a complete data profile of its performance, allowing them to see what succeeded and how to make future improvements to the thermal protection system. I am pleased that we have Ames local celebrities, Dean Cantinos and Chun Tang, who you may have met at the back booth already, who will talk about their Orion computer simulations and ArcJet testing we've done here at Ames. To optimize the design of the Orion crew vehicle, an 8% scale model was coated with pressure-sensitive paint and was tested in the Ames 11-foot unitary transonic wind tunnel. The testing simulated airflow and temperature changes the capsule will experience in flight after re-entering the atmosphere. The data collected is also essential to validating the accuracy of computational models that simulate the performance of space vehicles during planetary re-entry. The Orion launch abort system required testing in the wind tunnels at Ames to better understand the behavior of the system during a complex variety of launch conditions. The focus of the study was to determine the interaction between the plume from the jets and the airflow effects after separation from the rocket. Another test used a 6% scale model of the launch abort system in the 11-foot wind tunnel to find ways of minimizing how loud the system would be during an actual flight. Another local celebrity, James Ross, is joining us a little bit later to talk about the fluid mechanics aspect of Orion that was tested in Ames's wind tunnels. Built in the 1960s, how many people remember the 1960s?
Yeah. Heck
Those
yeah.
were good years, weren't they?
Yes, they were.
To support the Apollo's missions, Ames's horizontal free flight facility can fire models through a 75-foot long test chamber at speeds ranging from 500 to 18,000 miles per hour. Tests of the Orion capsule were essential to understanding how well the vehicle will fly through the air after re-entering the atmosphere, but before the critical parachute deployment. Ames also specializes in the use of computer modeling simulations referred to as computational fluid dynamics, or CFD. This work has been important to understanding the turbulent wake behind the Orion capsule as it slows down enough to deploy its parachutes. Studies have also been conducted to optimize the thermal heating performance of Orion by using Ames' developed software tool called Data Parallel Line Relaxation, or DPLR. Engineers will compare their predicted results with actual data from the Arctic test and data collected from the EFT-1 flight to improve the DPLR code for spacecraft design in the future. Another local rock star, Irene Smith, will join us later to discuss software contributions like the ACAUS diagnostic system and the user interface, along with diagnostic situational awareness. The scientists, engineers, and researchers of Ames are proud to have played a critical role in EFT-1 the EFT-1 flight test as NASA continues to move forward on its human journey to Mars. I hope you enjoy this program that we've created for you today, and thanks again for attending. I'd also like to thank all of our volunteers and all of our staff who are up at this ungodly hour for this really cool thing, and I encourage you to please join us for refreshments in the back and participate in some of the activities we've created for you. Thank you very much.
Thank you.